Hey folks, welcome back to the second video of the concept explainer in forces. So if you remember, the last video looked at the idea of what a force was, and we came to the understanding that a force is anything that acts on a body which causes it to accelerate. So today we're going to look at basically the idea of combinations of forces, because in reality you'll very rarely find something where there's one and only one force acting on it. So we're going to look at simple systems where there's maybe two forces acting on a body. And we're going to look at how, when you have two forces acting on a body, what can happen there. In order to understand how objects behave when you have two or more forces acting on the body, there's two things about forces we need to know. The first thing is that every force has what's called a magnitude. More common word for that would be every force has its own strength. So you can have weak forces and strong forces acting on different bodies. Another thing is that not only does it matter how strong the force is, but it also matters the direction in which that force acts on the body. So if you think about it with a car, you can put it into forward or you can put it into reverse, and the forces from the engine acting on the gears will cause it to accelerate in different directions. Or if you're doing something like a martial art, like judo or MMA, and you want to throw somebody, you can force them backwards, forwards, left and right. And in doing that, you can set up the circumstances for a successful takedown in those sort of situations as well. So the first thing we said is that forces have a magnitude, which means a strength. When we are drawing that, we simply just use arrows. Okay, so if we look at this force, and I say there's a force acting on some object to the right, and I say that there's another force acting on a different object, well, looking at these two arrows, we can simply see that the second force, F2, the length of the arrow is twice the length of the first force, so that would tell me that the longer the arrow, the stronger the force. So that's a nice easy way just to show how strong the forces are acting on objects. Longer arrows, stronger forces; shorter arrows, weaker forces. The other thing, as we said before as well, the forces have a direction. So again, if you imagine that you have somebody on your side and they're pulling on your arm, well, if they pull on your arm with this force, they're going to pull your body, in this case, to the right-hand side of the screen. But if there's somebody on the other side pulling you the other side, then what's going to end up happening here is you have a force pulling you to the right-hand side of the screen, you have a force pulling you to the left-hand side of the screen, and as we can see, they're the same length arrows, but they are in different directions, and ultimately you'll end up, your body is going to move nowhere, although you might end up with a bit of tension and pain in your arms and just under your ribs from people pulling you in two different directions. So here we have all forces have not only magnitude, but they also have direction. So once we understand those two ideas, we're going to look at combinations of forces acting on objects. So we're going to take a very, very, very simple idea. This idea is if you just take an apple and you let it go. And in class, you can just ask students, well, what's going to happen when you let go of the ball? They're going to tell you more than likely it's going to fall to the ground. Some kids who might be really tuned in might even tell you it's going to speed up as it falls to the ground. And then you ask them, well, what's going to cause that motion? They're going to tell you that's gravity. So you can just test it out. It doesn't have to be an apple. Any object in the lab will do. Let go of it. And we see that the ball falls down towards the ground. So the next thing we can do then is if we take a quick look at the same scenario again, and we say, right, well, there's the force of gravity. So it's the force of gravity that's pulling on the ball. Oh, sorry, on the apple. So again, let's look at that in terms of our arrows. And we know that once you let go, the only force acting on the body at that point is the force of gravity. And because there's only that one force acting, it's going to accelerate down towards the ground. Next thing I'll then tell the students is, right, I'm holding the apple in my hand. Is the force of gravity still working? Does the apple still feel the force of gravity? And some students will say yes, and some students will say no. So this is an important time for students to understand that just because it's not moving because your hand is in the way, that doesn't mean that gravity isn't acting on the ball or on the apple or on whatever object's in your hand. So in this case, yes, the force of gravity is still acting there. So the only reason it's not moving is because there has to be a force acting up. And because it's not moving, we know it's acting up and we know it's got the same strength. Now, this would be called the reaction force. In some cases, you can just say it's the force that you're putting on it with your hand. I'm just going to label it as that. So in this case, there's the force acting down from gravity on the ball, and there's a force from the hand acting up, which is being generated by your hand. Now, these are not force pairs with the way Newton's third law is, which I'll address in a later video, but these are two balanced forces acting on the ball, which means that they are the exact same magnitude, which means they have the same strength, but they're acting in the opposite directions. So in this case, the ball is not going to change its motion. This tells us that there are two types of forces when you start combining them. So when you look at a body, if the total forces are unbalanced, that means that the total forces do not cancel each other out, which means in some direction, the body is going to accelerate. Which means it's going to speed up, or in some cases, it might even slow down. If you think about it, like when you're driving in a car and you put on the brakes, that's going to be a force causing you to slow down. In the case of the apple, when it falls, the body is going to speed up, or it's going to accelerate. You can also have balance forces, which tell us that when two or more forces acting on a body, they do cancel out each other's effects. By saying they cancel out each other's effects, that means that their motion doesn't change, which means if the object is not moving, it will stay not moving. For instance, when you're holding the apple in your hand. But it also means if an object is moving, it's going to stay moving at the exact same speed that it is. An easy way to think about this, or a nice one that I would think of, is when rockets are flying in space, they aim at the target to where they're going to be. So let's just say they're aiming for the moon. They aim for the position they want to be to orbit the moon. They turn on their rockets until they get the speed that they desire. And once they hit the direction and the speed that they want, they turn the rockets off. What that allows is the rocket will just go through space at the exact same speed that it's going at. It won't speed up and it won't slow down. So it has balanced forces acting on it in that case, which turn out to be have a total value of 0 newtons, and that causes the rocket just to move through space at its same velocity. So balanced forces just means the motion doesn't change. If it's not moving, it'll continue not to move. If it is moving, it'll continue to move at the exact same speed. If it's an unbalanced force, it will accelerate, which means in some way, shape, or form, it'll speed up, slow down, or it'll change the direction of its motion. The next video we're going to look at is just going to go through some different examples of balanced and unbalanced forces.